Imagine the universe as a colossal playground with its own set of rules. Just like we have to follow the playground's rules to enjoy our games, the universe operates under the laws of physics. Humans, being naturally curious creatures, often get tired of the same old games and seek out new adventures. But before we can discover new horizons, we need to grasp the basics of our playground: space, time, and the rules that govern everything in this mysterious universe. We all know objects move through space, but they also journey through the ever-present dimension of time. Everything seems straightforward at slow speeds, but when an object approaches the speed of light, things start to get weird. For instance, would you be able to see your reflection in a mirror while traveling at light speed? And what would happen if you tried to change events by going back in time? Let's delve into these cosmic conundrums and solve the grandfather paradox along the way. In our vast universe, the speed of light is the ultimate speed limit. Nothing can travel faster. Even at a molecular level, information zips around at light speed. But here's a fun fact. We've never actually measured the one-way speed of light. We only have data from round-trip measurements, bouncing light off a mirror and back. We just assume light speed is constant in both directions. But what if it's not? Imagine Earth sending an important message to the first settlers on Mars. This signal was sent at midnight. Adjust your clocks accordingly. We know it takes 24 minutes for light to make the round trip to Mars and back. The settlers assume the one-way speed is half that, so they set their clocks to 12 minutes past midnight when they receive the message. But what if light traveled to Mars at only 50% of its usual speed? It would take 24 minutes just to get there. Unaware of this, the settlers reply, "Clock adjusted. Message sent at 12:12. Back on Earth, scientists think the message took 12 minutes to arrive, seeing a 24-minute difference. This example shows just how crucial understanding the speed of light is to unlocking the mysteries of time. So, what is time, exactly? We often think of time as the changing seasons or a tool for scheduling meetings. But time, represented by a ticking clock, is just a measure of movement. Specifically, our planet's orbit around the sun traveling through space and time isn't governed by the same rules. There's a speed limit in space, 186,282 miles per second, the speed of light. But is there a similar limit for how fast or slow time can move? Even here on Earth, where we orbit the sun relatively slowly, there's no universal clock. Time flows differently for each of us, as Einstein's theory of general relativity predicted. To see how strange the relationship between speed and time is, watch objects moving extremely fast. The faster an object travels through space, the slower it moves through time, a phenomenon known as relativistic time dilation. So, what happens if you travel at the speed of light? Photons, the particles of light, have no mass, so they always travel at light speed. For them, time doesn't exist. Their journey is instantaneous from our perspective, even though we see time passing as they move through space. Imagine a rocket traveling at 99.99% the speed of light. A passenger throws a ball forward. The velocities of the rocket and ball add up, as expected from classical physics. But if they turn on a flashlight, the light speed doesn't increase. Both the rocket crew and an observer on Earth would measure the same speed for the flashlight beam because light speed is constant, regardless of the source's velocity. This means time must adjust. Now picture yourself on a futuristic motorcycle, speeding down a long, empty road at the speed of light. You glance at your reflection in the side mirror, but the mirror is also moving at light speed. How would the light reflecting off your face catch up? If you see your reflection, an observer would think the light bouncing off your face is moving faster than light, which breaks the laws of physics. If you can't see your reflection, it suggests the light isn't constant. To keep measurements consistent, the universe has a few tricks up its sleeve. As objects approach light speed, they experience time dilation and length contraction, shrinking in length and rotating, known as the Terrell-Penrose effect. These changes are only real to us. A person traveling close to light speed would feel normal, with time flowing as usual and their body maintaining its length. To them, it's the outside world that seems distorted. Since motion is relative, distinguishing who moves and who stays still becomes elusive. It's like everyone wears unique goggles, each offering a different view of reality. Unlike optical illusions, time dilation is real and irreversible. When the rocket slows down and stops, the crew and Earth observers compare clocks and notice the difference. Time flows in one direction, pushing us forward. We've learned how to speed up our progress through time. But can we go back? If time stops at the speed of light, traveling backward might require superluminal speeds. For now, the speed of light is the ultimate speed limit for time and space. Even today, we can look back in time. Light takes 1.3 seconds to travel from the moon to Earth, so when we look at the moon, we see it as it was a bit over a second ago. Greater distances mean we observe a more distant past. Imagine one day, we can not only look back but travel back in time without breaking the cosmic speed limit. Scientists have suggested several hypotheses, like the Tipler cylinder, an infinitely long, massive, spinning tube. If we could build such a structure and spiral around it, we might travel back in time. The closer our ship gets to the cylinder, the further into the past we move. After calculating the necessary time, we shift the spacecraft away. According to the block universe theory or eternalism, time is like a block where every moment, past, present, and future, exists equally. In this view, traveling into the past is possible, but we can't change events. If the future already exists, all events are predetermined, and free will doesn't exist. This creates causal loops, where future events influence the past. In the grandfather paradox, you can't prevent your grandparents from meeting, as it would contradict your existence and the ability to use a time machine. But is it possible to change something in the past? Recent research suggests paradox-free time travel might be possible. The timeline would self-correct, ensuring the same outcome. For example, if you attempt to prevent your grandfather's meeting, someone else might intervene, or your target wasn't actually your grandfather. Quantum superposition, where particles exist in multiple states, offers another solution. A time traveler could exist in multiple versions of the past, with different outcomes. The universe decides on one outcome when observed, similar to the double-slit experiment. The many worlds interpretation suggests each time we travel into the past, a new universe branches off. You write a letter in Universe 1, travel to Universe 2, and give it to your past self. This cycle creates an intricate web of universes with different versions of events. Even now, every event with multiple outcomes spawns parallel universes. Consider the infinite monkey theorem. Given infinite attempts, a monkey could eventually type out Shakespeare's works. If something this improbable happens in our universe, it could prove the many worlds theory. Next time you encounter an unlikely event, think about the chances the universe flipped a coin and it landed perfectly on its edge. Do you think we'll ever make time flow backward, or is time just an illusion? Share your thoughts in the comments and stay tuned for more content like this. Thanks for watching.